So this is the session number 12, and let us start by taking your queries. So as we always do, I'll first take queries from the Google form, the queries that have been submitted in the Google form, and then we will take queries from live comments. Okay. So let me quickly just go to the Google form over here. So we are going, so till 135 we have dealt with in the last episode. So let us take this. So this question has been, so these questions have been asked by engineer Rohit R. He's from Shimoga, Karnataka, and he's an independent consultant. So let's see what he's asking and try to answer them. So what I'll do is I'll just copy it to just a minute. Yeah. Okay. So let me share my screen. Yes. So his first question is for peripheral beams, do we need to release the torsion as the bars in slab won't have enough development length? So do we need to consider it as simply supported? So I think yes. I mean, I don't think. I think all of you might be aware of this problem that you might have faced. That let's say this is a slab panel, and in plan view, I'm showing you these are your columns. Okay, these are your columns in plan view, and let's say these are your beams that I'm drawing in green color. So these green beams are the peripheral beams. Okay, and then you have got some blue colored beams which are your internal beams. So now what will happen? Okay, let's say I have a beam like this also. So now what will happen if I were to talk about this slab panel? And this is a discontinuous edge. Okay, this is a discontinuous edge of your slab panel. So the reinforcement in the slab that you provide over here, if I were to draw a section, it's quite obvious that uh, just a minute. This is my green colored peripheral beam, and then I have my slab over here. So the reinforcement, this is section AA, A, A, A. So the reinforcement over here, you don't have adequate sort of length available to develop this reinforcement of the slab in the beam. Even though you may have had, even though you may have had sufficient development length, let's say the beam depth was sufficient so as to ensure adequate development length of your slab reinforcement, still practically it becomes difficult on site to provide every bar with a development length over here. Practically it is difficult. So most usually we try not to have development length over here. Now if we are not having development length, the practice we adopt is that we'll just leave this bar as it is, maybe just develop it till the mid center line of your beam. In doing this, we are also serving one more purpose, and that is that this beam which we have, this will not be getting torsion at least from the slab panel. Okay, so if I don't develop a bar over here, uh, that means the moment will not be developed between the slab beam junction. That means the moment in this slab at the end, the moment in this slab panel at the end, uh, or at the edge of this slab in the end will be transferred to the beam as a torsional moment. So we want to avoid that torsional moment in our beam. That is another reason why I don't like to develop my bar, slab reinforcement bar on the discontinuous edge inside the beam. So I just leave it as it is. So that is what he's asking. For peripheral beams, do we need to release the torsion? Yeah. So because of all these issues, number one was problem with detailing. Number two was we do not want torsion in our beams because then there are a lot of design requirements that we have to fulfill if our beam is in torsion. And torsion in the beam leads to other issues also. So we like to avoid having torsion in the beams. Okay. So therefore, we are also not developing the slab reinforcement at the discontinuous edge. Now, because we do so, and because this is a case of compatibility torsion, that means even though or although we may not be designing this slab beam junction as a rigidly connected junction, it's a case of compatibility torsion because if you are not designing for this hogging movement, what will happen? It will be transferred to the sagging movement in the slab midspan, and over there we can consider that midspan movement, sagging movement, provide the reinforcement accordingly. So this is a case of compatibility torsion. So we are happy with not designing those beams for torsion. So therefore, we will release the torsion in all the peripheral beams. You can do that. All right. So there are now two ways. Either you release the torsion in the beam, release the torsion in the beam, but then the problem comes that what modifier should I give to the beams? Now in ETABS or SAFE, there are issues because some say you provide a 0.01 stiffness modifier for torsion in the beams. Somewhere you may read or listen to that there is a zero point 0.1 stiffness modifier to torsion that you need to provide. So that what exact value of modifier, stiffness modifier you would like to provide to these peripheral beams, that is again problematic. So another way to incorporate this is to give slab edge releases. Okay, so there are options available in ETABS to give the slab edge releases. So you can give slab edge releases to whichever slab edges which are on which are the discontinuous edges. Okay, so on all those edges you can give slab edge releases if you want to not get into trouble of assigning torsion modifiers to the beams. So there are two ways: either you assign torsion modifiers to peripheral beams or you give slab edge releases to the slab discontinuous edges. Okay, all right. Mr. Rohit, his second question is the artificial intelligence is disrupting in many fields. Will it also affect on structural design? Yeah, if it is affecting all the fields, it will affect structural design field also. But then, how it will affect or what will be the impact, I don't know, because in a fast-changing technical landscape, it is difficult to predict these things. Who would have predicted a month ago that you will get a cheaper AI model like the DeepSeek, which will break the what should I say, which will break the hegemony of uh, the American AI models, isn't it? We didn't think 1 month ago. Nobody thought so. So till let's say 1 week, 2 weeks ago, everyone believed that all the large language models are will only operate on brute computing power. That means you will have to have millions and millions of GPUs, and all those will be needed to train the model and all those things. But then the DeepSeek has shown that you can train the artificial intelligence large language model by lot less computing power, isn't it? So we really don't know how the things will play out. But see, wherever your intuitive understanding is required or wherever creativity is required in structural design, maybe that will not be so easily replaceable by artificial intelligence. Wherever genuine creativity or intuitive understanding of design is required. But yes, let's say if you are doing some manual calculations or if you are doing some computer software operation, maybe that can easily be uh, taken over by or handed to an AI agent, maybe. I don't know. Okay. Yeah. So I don't have much knowledge about it. So I cannot comment much. If possible, his third question is, if possible, make one session on complete cantilevers. What is the meaning of complete cantilevers? What do you mean by complete cantilever? I mean, I'm not sure what complete cantilever means. I think he might be saying that cantilevers that do not have a backspan. Is that what you mean by complete cantilever? So, if I'm understanding correctly, I'm showing you a sectional view. Let's say this is my beam, this is the cantilever, this is the column, and this does not have a backspan, and this is another cantilever where there is a backspan. So I don't know. He might be calling a cantilever without backspan as the complete cantilever. Backspan. Yeah. So if I understand his question correctly, he is saying, please, what's he saying? Please make one session on complete cantilevers. Or this might be he wants to say, please make one complete session on cantilevers. I don't know. Anyway, but since I have drawn this image, let me tell you that these cantilevers which do not have backspan, they are slightly more challenging, so to say, than the cantilevers which have backspans. Why so? Because of the backspan, your deflection is controlled. I don't know how many of you have observed. Deflection in the cantilever is reduced when you have a backspan, and when you are able to load your backspan, you will observe that the tip deflection in the cantilever will decrease. How many of you have observed it? No one? Okay. You may make simple, maybe a simple portal. Try to do it. So the moments as well as the tip deflection, moment and tip deflection in a cantilever which has backspan is lesser than the tip deflection and the moment in a cantilever which has backspan. Okay. No, sorry. What did I say? I'll just repeat the moment and the tip deflection, free end deflection in a cantilever with backspan is less than uh, the moment and tip deflection in a cantilever without backspan. Yeah. So, for example, if this is A, this is B, the moment in A and this in A will be lesser than the moment in B and deflection in B. So that is a problem these cantilevers have, which do not have any backspan. So then we need to be more careful about what deflection are you getting, what is the moment, provide reinforcement accordingly. And then here, as a thumb rule, as a practice, what we do is instead of providing LD, maybe I'll provide some more development length of the bar in hope that this additional development length somehow tries to control the deflection in a better way. So cantilevers without backspan are problem with a structural viewpoint, if you ask me. Okay, so I think this is what he means by complete cantilever. Although, yeah, means I could figure this as his question. Anyway, so these were his questions. Now let's go to the next question, set of questions. So just a minute. Yeah. So Mr. Alek Katuwal from Kathmandu, he is a working professional and he has some questions that he wants to ask. Let us try and answer them. Just a minute. So he is one of the regular participants in this online Ask AuxEn Anything series that we conduct. So he is quite regular with his queries. That's I must appreciate that thing. Yeah. So his first question is, what is the correct procedure for applying RITS analysis in ETABS? I do not know properly. So you can refer to the analysis reference manual in ETABS, where they will explain the ETABS RITS. I mean, eigen solution versus RITS analysis versus eigen analysis. They explain it, but because my knowledge in dynamics of structures is limited, I could not understand it uh, properly, so to say. So the procedure and the theoretical background behind RIDS analysis, RIDS vector or RIDS analysis, uh, you can refer the ETABS reference manual for it. I am not able to answer this question properly, so I am skipping this. His next question is, how can we model shear wall using section designer? So in the same manner that you may use section designers to model other sections, in the same manner you can model the shear wall section also. And I'll just show you what I just give me a minute. I'll just show you a few things. So what do I do? Okay, so I won't be able to share my screen, is it? Okay, so anyway, I'll just write down the process that you should follow. So you go to the section designer and choose the shear wall, let's say whatever dimensions you want. Let's say this is D, this is L. Okay, and then there are features in the ETABS section designer to define the reinforcement also. So in fact, you can choose your own reinforcement arrangement and layout, whatever reinforcement arrangement and layout you want to provide. You do that. Suppose in the boundary element you want to provide this kind of a reinforcement, you could do that also in the section designer. Once that is done, then you use this section designer and you may either use the check the section or you may use design section command. Okay, and once this is ready in the section designer, then you can take this section that you have created and assign it to the. Okay, yeah, good question. So correct, I got your point. Yes, so in that case, see, in that case, this shear wall, you will have to model it as a line element. Okay, you will have to model it as a line element. If you have chosen to make a section designer for it, then you will have to model the shear wall as a line element. Otherwise, section designer won't work. If you want to model your shear wall as a shell element and then you want to give the reinforcement as you desire, then there is an option in shear wall design in ETABS by the name of uh, define peer sections. Okay, so in the define peer section option, you can give the reinforcement arrangement as you wish to do so, as you wish to provide. So in the shear wall design option, there is a define general peer section option for to define general peer. Over here you can give the desired reinforcement layout. Okay, yeah, actually this is a good question that you have asked. So I'll just again repeat, if you have defined a section using section designer, then you will not be able to assign this section designer section to a shell element. You need to assign it to a line element in etabs. So in that case, you need to model the shear wall not as a shell element but as line elements in etabs. And suppose you have modeled your shear wall as shell elements, or as shell elements in etabs, and then you want to define a general reinforcement or customize the reinforcement, then you go to shear wall design options and go to define general pier section, and over there you give whatever reinforcement arrangement you want to give. Okay. Okay, good. Right. Okay. So going on to next question, we define rectangular pad footing thickness in safe. How can we convert it to trapezoidal footing? Okay, good. So suppose you have got a footing thickness of, I'm drawing a cross-sectional view. Now suppose you have got a thickness of 1000 mm and you want to optimize this. Of course, I have taken a case of isolated footings. That means a single column resting on a single footing concentrically, let's say. So now you want to reduce this thickness, optimize it. You want to make it trapezoid. So the thing that you need to keep in mind is, number one, at the free end, you will technically get zero movement and zero shear. So at the free end, if you are getting zero bending moment and zero shear, then do you need any thickness? So the answer is no. So if you ask me technically, you could also have a zero thickness at the free end. But then our code says that please don't provide zero thickness, give at least something. I think code tells you to provide a minimum of 150, I think. 150 or what? Uh, SP34, they have given this section, this image, this figure, sorry, 150 or 200, I don't remember correctly. We usually give at least 300 over here in practice. So see, if you have given this minimum 300, so already because of this that you are going to maintain, your thickness at every section will automatically go up. Otherwise, what would have happened? The thicknesses at corresponding sections would be lesser, but because we are maintaining minimum 300 at the free end, automatically your thickness at every section increases. That's a plus point. Now further what you do is that for column starter bars, or for column starters, you need at least, let's say, 75 mm over here, because you will be placing the column formwork, etc. So let's say I provide 75 mm over here. So now what do? You join this. So this is 75, this is 300. You join this. So you, in this manner, you may get a trapezoidal cross section. Did you understand so far? Hello? Something like this. Now, what are the things to keep in mind? The thing to keep in mind over here is that, let's say now I was to check the distance, one-way shear at distance D. So at distance D from face of the column where I wanted to check the one-way shear, you are not getting the 1000 mm thickness now. So you are getting a reduced thickness. All right. So you are not getting the desired 1000 mm thickness. You are getting a smaller thickness D2. So now when you want to check the one-way shear, you should be able to ensure that this thickness D2 is safe to take this one-way shear at this section XX, let's say. All right. For this, what one trick designers use, that let's say you have provided reinforcement over here. Okay. So suppose you provided 12 at 150 as your tension reinforcement. Now this tension reinforcement 12 at 150, if I were to calculate PT at this section, let's call it the section 1. So if I were to calculate PT at this section 1, and if I were to calculate the same percentage steel at section 2. At which section will you get more PT? Tell me. Anyone in the live audience? At which section will you get more PT? Percentage steel. Suppose I wanted to calculate the percentage steel at section 1 and percentage steel at section 2. Where would you get more PT? So you would get more PT at 2. So why so? Because what is percentage formula AST upon BD? Now what is happening at the section 2? Your depth is reducing. AST remains the same, B remains the same. Depth is reducing. So the PT at this section 2 is more than PT at section 1. So now because PT is more, Mr. Gaurang is saying PT1 is more. Arre, no, no. Did you understand my logic, what I just said? Why PT2 is more? So I said PT2 is more because imagine that I'm providing the same reinforcement 12 at 150 at the bottom. What's happening at section 2? The thickness of that section is less. So if thickness is less, PT2 becomes more than PT1, isn't it? AST upon BD. This D is less at 2. So the overall value becomes more at 2 than 1. So what they do is they use this trick and they say that because PT2 is more than PT1, they will say that the tau c value at 2 is more than tau c at 1 from table 19. And that is the trick many designers use. And then they say that the shear, one-way shear check may pass for reduced depth also because of more PT and because of more tau c. You got my point? So many engineers use this trick to decide the trapezoidal shape in this manner. Okay. If you and I think I mean it's okay because if you look at table 19, it gives you the tau c value on the basis of PT percentage. So I think you may be justified in doing so. If you don't want to use this sort of a thing, then the best way is to give a trapezoid shape after d distance. So what do you do? You give a trapezoidal shape after d distance from face of column, where d is the effective depth. So in this way, you ensure what? That the one-way shear, which was critical at d distance, there you are getting the full required depth, and then your taper starts. So you may do this, you may do this, or you may use this trick that I just explained in deciding the trapezoidal profile. So I hope this is clear. Mr. Gaurang Kerkar is asking, as you say, SP34 considers some thickness, but zero shear. No, I was saying at the free end, at the free edge of an isolated footing, you have zero shear, zero moment. So technically no thickness is required, but still we provide certain minimum thickness at the free end as per the codal requirement. So that need not be optimized. You give what is minimum over there also. You give as per the code. So if your code SP34, it is showing you minimum 150 or 200, whatever, you give that. And generally from a practical viewpoint, because then you have to put your shuttering and all those things. So we always try and give at least 300 over here. Okay, not less than that. Okay, good. So this was about the sloped footings, trapezoidal footing, sorry. And in the same manner, you can give the step footing also. Okay, so the same logic you can adopt for giving step footing. So wherever or however you decide the profile of the step, ensure that at every step you check the one-way shear and also check the punching and accordingly decide the step profile. Again, the same logic you can adopt. So the PT you can increase where the thickness of your footing reduces, and because of the increased PT, your tau c values increase, and that advantage you can take in shear checks. Very good. So this is done. Then Mr. Alex, next question is for bearing pressure check exceeding safe bearing capacity in safe, is increasing the footing size the only solution? Yes. If your SBC check is failing, that means the bearing pressure below your footing is more than the safe bearing capacity of the soil. The the option, the only option I would say that is available is to increase the footing size. Okay. This statement I have made assuming you don't have the option to provide an additional element like pile. Suppose you had the additional option. Suppose you had a conducive substrata where you could provide piles also. Then you can think of providing piles below your footing. Understood? So then what will happen? Those piles will take that load from your superstructure and in turn help you to reduce the bearing pressure below the footing. So that is one option. If not, if let's say you don't have the strata suitable to provide piles, then there's no other option but to increase the footing size. Okay. And by footing size I mean plan area. Increasing thickness will not help you. You need to increase the plan area of the footing. Very good. So these were some interesting questions he had asked. Although they were basic questions, but still very important questions that he asked. Very good. So then we go to the next question and let's see what do we have. Okay, wait a minute. So next question is asked by Mr. Yogesh Devre. He's from Pune and he's a working professional. How to apply temperature load in ETABS? So see, temperature loading in ETABS, you need to go to IS 875 part 5 where they have told you first of all you need to figure out what is the max min temperature at the location where you are designing your structure. Now even before that you need to figure out whether your building or structure is going to be exposed to outside weather. Generally RCC buildings, because they are covered by masonry walls and because of those masonry walls they have a good amount of insulation that masonry walls provide. So usually if it's a normal masonry building, masonry means if it's a normal RCC building with masonry walls, temperature loads may not be so important over there. But let's say if you had a steel building which was exposed, in that case you may have to think about temperature loads. So how to apply those temperature loads? You can go to IS 875 part 5. Over there they have given the isotherms. Isotherms means places on the map where you may expect similar maximum temperatures. So they have given isotherms for maximum and minimum temperatures both. So from there you pick up the min temperature and the max temperature at a place. So for example, suppose the max temperature at your location was 45 degrees Celsius, minimum temperature at that same location was to drop to 3 degrees Celsius. Then what do? You consider the temperature variation over and above the ambient, which we usually assume it as 27 degrees. So now you will say that the temperature expansion will happen due to the max, sorry. So expansion will happen due to your T max minus T ambient, that is 45 minus 27. So that is how much? 18. So for 18 degrees Celsius, your maximum expansion will happen. So in ETABS, you can apply directly for temperature loading. There is a direct option to just assign the temperature load in form of temperature differential. And then what it will do, it will calculate, the software will automatically calculate the alpha, which is the temperature coefficient, into, what does it do? Alpha strain is delta L upon L, and what do you do? Alpha into what? Alpha into, uh, anyone please? Alpha into your temperature differential into the original length. Is that correct? Hello. This will give you the change in length. Yeah, I think so. I think so. We have written it correctly. Yeah. So this gives you the change in the member length, which is equal to the temperature coefficient into the temperature difference into the original length. So this, your software is automatically able to assign it to the members. Similarly, you find out the delta min also. That means the temperature drop below ambient. That will be, let's say, 3 minus 27 minus 24. So you make another load combination, another load case. So you make two load cases. One is your, let's say, temperature expansion, T expansion. One load case you name it as temperature contraction, and then you assign these delta values, and then assign those to your member. Automatically the software is able to calculate the difference in the length and accordingly apply those temperature load cases, and then you can include them in the load combination. Okay. All right. So this is the method as per the IS 875 part 5. Now if you are dealing with some structure, let's say a bridge like structure, then you need to go to IRC 6. In IRC 6 they have given a slightly different approach to calculate these temperature loads. So you may go to IRC 6 for that approach. Okay, very good. Okay, so then we move on, and the next question is, uh, the next question has been asked by Mr. Oves from Srinagar. He is a working professional, and he is asking, okay, very good. How do we ensure, let me just copy it. How do we ensure, Mr. Oves is asking from Srinagar, how do we ensure ETABS and STAT model? Acha, how do we ensure in a ETABS or STAT model that some columns act only as gravity columns and not as a part of lateral load resisting system? Very good. So see, most of you might have seen this provision or seen these requirements in the code, that they want some columns to be gravity only column. So it is easier said than done. Code quite conveniently tells you that this column you treat it as a gravity column, this column you treat it as a lateral load resisting system column, and whatever. So practically it becomes quite difficult to ensure it. I'll just try to explain how. So, and I must tell you one clause over here. uh, I think that clause is given to you in 13920, I guess. It is interesting to read that clause, because that will help you to understand what your code really wants you to do and how difficult it is to do it practically. Let me just try to find that clause. Gravity. Right. There's no gravity columns. Just a minute. Just give me a minute. I'm just trying to search something. I should have kept it ready, but then I did not. Mm. In 1893 part 1 also they have not given gravity columns, is it? Can anyone just find out the definition that is given for gravity columns? I think it is in 1893 or 13920. Anyway, I'll just tell you what I wanted to tell. Mr. Chinmay is saying look for it in 13920. No, I look for it, but I'm not giving the. Yes, this is it. Yeah. No, no, not this. Okay. Anyway, so I'll just tell you what I wanted to tell. So see, gravity columns. The code means that the gravity columns should not resist. Let's say this is an EQ force acting. So the gravity columns should not resist the effects of your lateral load. Now, what are the effects of lateral load? Tell me in this portal frame. Let's say this is C1, this is C2, this is C3, C4. Now, what are the effects of lateral load on this portal frame? So, the effects of lateral load will be end moments or moments in the column, bending moments in the column, shear in the columns, and axial load in the column. Do you agree with this? Hello. Do you agree with this? Yes or no? So, because of the lateral load that is acting on this portal, all your four columns, let's call them C1, C2, C3, C4, will 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 have to resist bending moments, shear forces, and axial loads and under the effect of EQ. Now, your code says that the effect of lateral load should not be taken by the gravity columns. So now the interesting thing over here is that how do you, that means it should also not take axial loads. Do you get this point? So there should not be any axial load that gets transferred to your columns that you want to designate as gravity columns under the effect of lateral load. See, one axial load is due to the gravity load that is acting. So because of this gravity load, all your columns will take some gravity load. We are fine with that. But what we are saying over here, that the axial loads generated in the columns due to effect of lateral load, those should not be taken by gravity columns. Why? Because your definition or your code says that whichever column you are designating as gravity column, it should not be taking the effect of or induced effects of lateral loads. Okay, so here comes the implementation problem. Do you understand what is the implementation problem? So the implementation problem will be that, let's say in ETABS or STAT, suppose I wanted to assign C2, C3 as gravity columns. So that means I do not want any lateral load to be transferred to this C2, C3 because of the, sorry, I'll repeat. Suppose in the ETABS or STAT model, I want to assign or designate C2, C3 as my gravity column. So what does that mean? That no bending moment or shear should be transferred from this EQ in C2, C3. So doing that is simple. We may detail let's say the connecting beams to these columns as released beams, moment releases, and we can ensure that on site also. So when I do the moment release, what happens? The moments due to the effect of EQ will not be transferred to C2, C3. Do you agree with this statement, please? Hello. So that thing sort of gets satisfied, but then what we are not able to satisfy will be the axial loads that still get transferred. So we still have a problem with the axial loads because of the connectivity between the column and the beam. The axial load will still get transferred because of the lateral load. Now, how to ensure that even the axial forces should not get transferred to C2, C3? Because we have to design and detail C2, C3 as purely gravity columns. And by gravity columns, I mean that no effect of lateral load should be transferred to this C2, C3. So now this is a big implementation problem, and we really don't know what to do in such cases because code does not tell you a proper process. So now most of the things that are done from here onwards is a pure jugaad that is adopted by practicing engineers. So one of the jugaad is to do what? One of the jugaad will be to nahi, what will be one of the jugaad? Hmm. So one of the jugaad can be to give a very very small axial modifier. One of the jugaads will be to give a very small axial modifier to this column. But then when I give the axial modifier to this column, the problem will be that even the gravity loads then will not be properly transferred. So giving the axial modifiers may not work. One of the other jugaad can be to replace this column and just give some supports over here. But doing this means what? Doing this means what? That you are going to alter the stiffness of the system. Now, when you alter the stiffness of the system, what will happen? The time period will change. And suppose you are doing a response spectrum analysis and your time period gets changed. Again, there will be a problem of lateral load calculation, isn't it? So in such cases, what do you have to do? You have to make multiple models. So first you make, let's call it as a gravity only model. So here what you do, you just assign gravity loads and analyze your system for these gravity loads. Okay. Once you have these gravity loads, no, I mean keep this model aside. Then you make another model where you just make a model for lateral loads. Now, in this lateral loads model, what do you do? That you replace the columns with a pin support. Or no, no, don't do it this way also. Wait. You make your full model, let's say. Okay, let's say you make your full model, assign lateral loads or find out the time period and find out the lateral loads that will be acting on this system because of the whatever time period you are getting. Okay, so from here you find out the lateral loads that are going to act on your entire structure. This is a full model. Find out the lateral loads acting on this model, maybe floor wise. Take those loads, assign into a new model over here. Let's say in this model where you have removed the columns and just kept some pin support like thing, so that so that none of the lateral loads get transferred to these gravity columns. So you have replaced the gravity columns with, let's say, pin supports. Now here you assign the same lateral loads that you got from original model, maybe through diaphragm assignment. Okay, and in this model you just design the LLRS. Are you getting my point? What I'm trying to convey? So in this, you just assign the lateral loads that you got from your earlier model, and just design the LLRS, lateral load resisting system, over here. Okay. Now once you get those drifts and lateral deflections, then you do what? Then you go back maybe to your original model, and over here you design your gravity columns for the moment that will be induced due to this lateral sway delta. Okay. So additional moments you find out that will be induced due to this lateral sway delta, and for those additional moments you ensure that your gravity columns are designed, plus of course the gravity loads. So of course the gravity loads will be there. So in this model, oh no, okay, you create a third model. Okay, quickly repeat. I'll just quickly repeat. You see, you make a model. Let's call it as the model one. In the model one, what you do, you make your complete model, find out the system time period. If you want to run a response spectrum, run a response spectrum, and you get the EQ forces. Now you make a second model where what you do here, you remove the gravity columns and replace it with pin like supports. Here you assign the same lateral load that you received in this first model. You assign the same lateral loads, maybe through diaphragm assignment. So lateral loads from 1 is assigned in this model, and doing so you get the lateral deflection or sway delta. Now you make another model, let's call it the model 3. Over here what you do is you make the entire model, have the gravity columns also over there, but then what you do over here, you just assign the gravity loads only, don't assign any lateral load to this system. And over here you add additional moments on the gravity columns due to the lateral sway delta. Okay. So that additional bending moment you assign to these gravity columns, and for that you design this gravity columns. Okay. In the second model you design your LLRS, and in this third model you can design your gravity columns only. Is that clear? So maybe this type of a jugaad work you can do. I know it's quite complicated to hear all these things, but yeah, if you want to satisfy all the codal provisions, I think this is the jugaad that you need to sort of uh, yeah, this is the sort of jugaad that you want to do. Okay, that you need to do. Okay, so this was about the gravity columns and a possible way to implement those provisions. Now we have another question from Engineer Chinmay Sarkar. He is joining us from Kolkata. He is a working professional. He is saying, in flat slab design, should we design the slab considering lateral load or design simply for dead load plus live load? Very good. So see, again, if you have a pure flat slab, now because of this discussion that we just had, what is your lateral load resisting system? Do we assume that lateral loads will be transferred through flat slab column system? Yes or no? Hello. Lateral loads, do we assume them to be transferred through the flat slab column junction? Answer is no. Usually we don't assume any of the lateral load to be transferred through the flat slab column junction. So the lateral loads, we assume that they will be transferred through some shear wall system, which we will have with our flat slab system. So then the problem is similar to the gravity column problem that we were discussing, that your flat slab column is not to be designed to take any lateral loads. All the lateral loads we will assume will be taken by your shear walls connected, and that's why in flat slab system you have to have shear walls added. This is as per the Indian code I'm saying. So flat slab shear wall will take the lateral loads. Flat slab columns will not take lateral loads, but then they have to be compatible with the lateral sway. So the sway will happen to all the system, all the structure together. So this will sway, everything will sway. So just like I was discussing in the gravity columns, what you need to do is you need to ensure that although the flat slab column junction will not take the lateral loads, it has to be designed for the deformation compatibility. So you need to design this junction for the additional moment that will be generated due to this deformation compatibility. Additionally, because punching shear is a problem, your ACI 318 tells you, I don't remember it exactly, but you need to reduce the punching shear stress to zero point 0.4 times tau c, especially under the case of lateral loads on flat slab systems. Uh, when you are checking punching, column punching with flat slab, you need to check it for a reduced concrete shear stress, and I think they need us to reduce it to as low as zero point 0.4 tau c. Okay, so these are some of the uh, what should I say? These are some of the steps you may have to take while designing a flat slab column junction, especially for lateral loads. Okay. Then Mr. Chinmay is asking for non-structural walls. Should we draw it in ETABS model or just apply the load? No, so you find out the planned density of the wall. If it is less than your IS 1893 limit of I think 20%, what is the non-structural wall planned density? 20%. If it is less than 20%, you may not model the non-structural walls. Otherwise, you need to model your non-structural walls as bracings, as X braces, and the formulation is given in IS 1893 Part 1 about what should be the section size of that brace that you need to consider, or what should be the stiffness of that bracing that you need to consider. All those things are given to you in the IS 1893 Part 1, provided that the non-structural wall plan density goes beyond 20%, I think. Okay, if it is less than 20%, then you need not do anything. You may not model the non-structural wall. So just apply the load, forget about the modeling, forget about modeling it. Clear? Very nice. Now, so these were the questions we were asked on the Google form. Now let me take few questions. Now let me take the questions that have been asked on the live comments. So civil engineering software and site knowledge. He or she is asking, my question is that if eccentric footing, my question is that if eccentric footing, in eccentric footing, the bottom and top mesh reinforcement is provided, is it sufficient or any method of providing? So from a stability point of view, just providing top and bottom mesh reinforcement will not work. You need to provide a tie beam, or you need to provide a strap beam, or you may have to provide a pile to take care of the moments that you get at the base of eccentric footing. So that you have to provide first. The mechanics, you need to first ensure that your eccentric footing is stable, and then whatever reinforcement requirement is there, you provide. Okay, so by providing reinforcement, you cannot say that mechanics will be resolved. No, the problem of mechanics has to be sorted out first. Okay, Mr. Akash Babar, engineer Akash Babar is saying, asking rather, no, he is saying, please provide your views and thoughts on proposed draft of IS 456. I have not gone through that preliminary draft, so I am unable to provide any thoughts and views on it right now. Mr. Gaurang Kerkar is asking how to know the exact loading on beam. His question continues, if adjacent slab is one way, beam is 9 feet by 17 feet, so how to know the loading, which type of it, and how and which type of reinforcement provide with some thumb rule? No, no, don't go much into thumb rule. You will need to do some quick analysis. For load transfer between slabs and beams, I think you might be aware of the approximate load distribution using the yield line theory. So if this is the slab panel and these purple color elements are the beams, then we assume a load distribution between slab and beams approximately by this sort of a triangular trapezoidal thing. So that means this load will be transferred to this beam and this load gets transferred to this beam. Load on this area gets transferred to this beam and so on. And these processes you can easily find in any of your book. So generally this angle is considered to be 45-degree, and if this is my short span Lx, this is Lx by 2, this is Lx by 2, and then you can find out all the dimensions, find out this area, find out how much of the load is getting transferred to the beam, and in this manner you can work out the approximate load transfers to your elements. Okay, you can easily get it in any preliminary book, first second year book, you will get to know. All right, so once you have the loading, then you need to analyze your beam accordingly. You need to find out the reinforcement. So giving thumb rules, I think it will be very generic, and uh, thumb rules cannot be given in such a case unless you don't know the complete situation. Yes, civil engineering software and site knowledge. He or she is asking, in pile foundation, the pile is not cured for 28 days period. How is the pile strength achieved? Yeah, so very good. So usually, even though there is no curing, yeah, we do assume that the moisture from the soil will be absorbed, and that soil moisture will give it a good curing surface, or it will provide a good medium for curing. Also, generally in piles, you must have seen that we follow a concrete of higher workability. So, curing usually does not become a very big challenge in piles, usually. Third point is that because piles are not exposed to sun, or because they are not exposed to weather, generally the moisture loss is comparatively very less as compared to your other elements which are exposed to sun and which need immediate and long sustained curing. So because of all these issues, usually we are not very worried about pile and its curing. Okay, the next question is by the same civil engineering software and site knowledge. I see in actual site, as per calculation, the two-way slab is needed, but they are providing one-way slab, and spacing is also more. Oh, so see, one thing you must keep in mind, that just because you provided reinforcement like one way does not mean that your slab will behave like a one way. Your behavior of slab depends on the aspect ratio of the slab and how it is resting on the beams. So you have to be very careful. I have seen people, just like you mentioned, that they will provide reinforcement only in one direction and they will assume that your slab will behave in the desired manner. No, it does not happen so. Your slab will behave as per the aspect ratio and as per the beam framing. So you need to be very careful with it as structural designers. Yes. Any more questions? No. Okay, are there any more questions? Okay, so I think those were the questions today. So we have taken all the questions from the Google form, and we have also taken all the questions in the live comments. Yes, please. Any more questions anyone has? Okay, then. So I think that's it. Oh, we have one more question. So, civil engineering software and site knowledge. I don't know why this name is like this. Civil engineering software and site knowledge. Maybe this is some YouTube channel. Whole building is designed as factored load, but footing is designed as per unfactored load. Please sufficient answers. No, no. See, you must understand the plan size of footing. When we find the plan size of footing, the plan size of footing, we find out on the basis of column load. So whatever is the column load, we will find out the bearing pressure, and from the bearing pressure, we will work out the plan area of the footing. Now, when we are working out the plan area of the footing, because we are comparing with the bearing, sorry, we are comparing with the bearing capacity of the soil, and that is not the ultimate bearing capacity, rather it is the safe bearing capacity, or so to say, it is the bearing capacity at working loads. That is the reason why when we are finding out the footing plan size, we take the service load in the column. So why are we taking the service load or the unfactored load in the column? Because we are going to compare it with the safe bearing capacity of the soil. So because we want the capacity and demand both to be at similar levels, therefore, as the soil bearing capacity was at the working level or the safe level, that's why the column load we will also take it to be the unfactored load or the working level. Now, once we find out the plan area of the footing, and now when I want to design the, or when I want to find out the thickness of this footing, while doing those calculations, then because we are again going back to IS 456 for doing these thickness calculations, once again we will convert the bearing pressure below the soil to ultimate level by multiplying it by the 1.5 factor. So we'll do it 1.5 into bearing pressure below the soil, and for this bearing pressure, then we will find out the one-way shear, two-way shear, whatever, and then find out the footing thickness. Is that clear? So when you say that for footing design we are using unfactored load, please remember we are using unfactored load only for calculating the plan area of footing, and the reason is because we are going to compare it with the safe bearing capacity of soil, which is at the working level. So that's why we are, see, suppose we were to compare compare it with the ultimate bearing capacity of the soil, then we would have taken the ultimate load in the column. But because in the geotechnical reports we are given the safe bearing capacity, that's why we take the working level load of the column. Once the plan area is found out, then while calculating the thickness of the footing, then we will go back to our IS 456 calculation process. So then we will need the ultimate level loads. So then we will multiply the bearing pressure by the 1.5 factor. Clear? Very good. Yes. Anything else? So all these things we have discussed in quite detail in our foundation design course. Yeah. Okay, Mr. Rutik is asking these questions. He is a recent postgraduate student. Very good. Mr. Gauran Kerkar is asking, shall we use uniform spacing of ties in foundation? Why do we want ties in foundation? Any specific reason? Oh, you mean to say the confinement reinforcement that we continue till the 300 mm inside the footing? Is that what you are asking? Okay, so you can refer to IS 1893. Sorry, you can refer to IS 13920, and proper guideline is given to you about what is the spacing you need to maintain for confinement reinforcement at different locations, uh, what to maintain inside the footing, what to maintain inside the beam column joint, what to maintain near the beam column joint. All those things are given in detail. Just go through 13920. Okay. Okay. Anything else? Okay then. So I think these are the questions for this week. Thank you everyone for joining and putting your queries and doubts. So I think that is all that we have for this week. Now we'll see you next week with another episode of Ask AuxEn Anything. So till that time, that's it from all of us. Thank you.